Okay, so in the last movie we found a nice, simple situation. Now let's go back to a more complicated situation. You can make one up.
How about we do like something like 24 times just some number, but 24 times 9.
All right. All right. So what happens here?
So let's see if we go down. Oh, this 12. 6. This goes to 72. 3. And then so we have 144 times 1.5.
That's just 1.
And we have so.
All right. This turns out to be a really nice example.
So if we're turning the 1.5 into a 1 here, if we have 2 times 72 is 144. 3 times 72 is going to be 1.5. That's what we found, 1.5 times.
144.
Yeah. And then if we round down to 1, we have to add back in
A 72.
72 so that it's equal still. Because this is a half of 44. We've already got 1, we just add a half.
Okay.
So that maybe gives me an idea, because adding all these odd numbers on this side when we have 2 random numbers, that's just adding back in a number that you missed by rounding down. Like, as when you round down, you get rid of a half and you're going to be short on some number.
Okay.
And those odd numbers that you add back in, or the numbers in the odd columns, are just sort of filling that space.
All right. So be careful when you say the odd numbers and the odd
Or
columns.
the odd numbers in this column,
in that column.
and then the numbers that correspond in this column
Okay.
are sort of filling up the gaps they need to fill.
All right. So let's let's walk down the rows here. 24 times 9. How does that relate to 12 times 18?
It's the same, because you doubled this and halved that.
All right. Now your turn. 12 times 18. How does that relate to 6 times 36?
It's the same because you're dividing by 2, multiplying by 2.
All right. And how does that relate to 24 times 9 then?
Well, they're still the same. You're dividing by 4, multiplying by 4.
Okay. Now what about 3 times 72?
It's still the same.
So the same as all of these, because you just divided by 8 here and multiplied by 8 there.
Okay. And how does 1 times 44 relate to 3 times 72?
It's not the same.
Right.
It's different.
Maybe a little different. It's the same.
Because it'll be smaller, because we divided by 3 on this side and multiplied by 2.
Okay.
And so we have to, we're going to have to add something back in, since this is going to be 2/3 as big as this was.
All right.
We have to add back in a third, or 72 here at least.
A third of what?
So this is 2/3 as big as this was.
Okay.
So we need to add back in a third of this
Uh huh.
to this to make it equal to what that was.
Okay. That's an interesting explanation, and it's correct. We have to add in 1/3 of 3 times 72, which is what?
72.
72. But we were not dividing by 3.
We divided by 2 and then rounded down.
Okay, so give that explanation.
Well, so we only have so 3 times 72 is 1.5 times 144. But if we drop that, then we need to add back in a half of 144.
Okay.
So that's going to be the number above this one because you're multiplying by 2.
Ah.
So it's going to be half.
Very good. So do you have a sense for why this algorithm works now?
I do.
Yeah.
Okay. Go ahead. Tell me.
So when you were working with going down the list and you just finding even numbers, then it's obviously going to be the same because you're just dividing by 2, multiplying by 2. And when you get to odd numbers, the reason you're rounding down and then multiplying them back in is that when you round down, you're missing parts of you need to add back in parts to make it equal, and specifically halves. So, and then we know this, the thing above it is a half of the number below it, so we add back in that number, and it will be equal still.
Cool.
And then we just add it up and it will work.
All right, good. That's great work, guys. Hi, high five. Good job. Good job this morning.